So, good evening, everyone. I'm Prableen Kukreja, working as a PhD scholar in IIT Tirupati. So, let's start with today's class. We are in lecture 6, but we have to do LDA today. Am I right? So, let's start. Any doubts till now? Yes. Any doubts? Any doubts in logistic regression? What we have covered: linear regression, logistic regression, shrinkage methods, and all. Yes, come on. So, let's start. Last time we left with LDA, linear discriminant analysis. So we had some assumptions the assumptions were that it should be Gaussian in nature, and then we also studied what is Gaussian in nature, what are the properties of the class which is being Gaussian. Then we studied about the multivariate Gaussian formula as well, how it is derived, some intuition behind that we studied, and then we studied that okay, here we are assuming in LDA that covariance matrix is same. Basically, the covariance is same for all of them. The variance is same, but the mean is basically changing. So it's just like the shape will remain the same, though it will be shifted away. Any doubts in this thing? Yes, come on. We'll cover today the MCQ part as well, as discussed in the last class.
Ma'am,
Yes.
ma'am, can we get the recordings of the live
Yes, yes,
classes?
yes. Recordings are there in the YouTube channel.
Recordings of the live classes, like
Yes, yes.
the recordings you are taking the
Yes,
lectures.
yes, 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 yes. That's what I'm saying. Maybe I'll write the YouTube channel of mine in which I am putting all the recordings side by side.
Okay, ma'am. Thank you.
So I have written in the chat. You can visit the channel and you can see, as well as I'm also putting the notes as well. So you can see the notes also, PDFs of notes also in the drive.
Okay,
So
ma'am.
in LDA, any confusion? LDA we have discussed only. There is an assumption that the data will be Gaussian in nature, and the other assumption is and the other is like the covariance will be same, like the variance will be same, the mean will be changed. Any confusion in this assumption? Should we proceed? Yes, Gaurav, Megha, Sachin, everyone. Should we?
Yes, we can proceed.
Yes, ma'am, we should proceed. Yes.
Hmm. So as we have discussed when we did logistic regression, log of odds, in which we saw that okay, there is a probability of log of probability of success over probability of failure in the binary classification, and when it is more than two classes, we are taking a reference class. Similarly here also, if I say, so what we are saying here, the same way, log of odds only. The log probability, if the given x is this and it belongs to the k class, probability some reference class. So Suppose two classes are there only, not multivariate. If two classes are there only, and it's success and it's like the other class, and if they are same, what does it mean? If it's same, any idea? I'm giving an X. There's same probability. Yes, Gaurav. Your voice is cutting. You're not,
Should be 1 minus whatever.
Gaurav, you're not audible. Like, can you write in the chat either? Your voice was cutting. One numerator. Okay. Okay. One numerator. One, obviously, log one it will be. But what is the intuition? I got it. You are saying that log one it will be. But what is the intuition? If I'm saying that I'm giving an X, these X data points, and it is having the same probability that it will lie in the class K, and it is having the same probability that it will lie in the class L. What we do basically, what we do is like, if we are giving a data point, it is having the high probability that it's in class K. Suppose I give a data point X, it's having the high probability, and we do some training and all, and we check that most of the X are lying in the class K, and then in testing what we'll do, okay, X belongs to class K. That will do. Why? Because we are saying that the probability of X lying in class K is more. Now what I'm saying is the probability of X lying in class K is equal to the probability of X lying in class L. What does it mean? Can anyone think? Like, you're right, Gaurav, you are talking about the mathematics part. Now what I'm asking is the intuition behind it. Yes, Suma, Sneha, Sneh, Satyarani, yes, everyone. Pratik, Prashant, Jayashree. Come on. What do you think? X lies in class K is having the same probability X lie in the class L. So in which class it is lying? Is it left hand side, or like suppose it these all points are in class K and these are on all L. Now I'm saying it is having the same probability. Now where it is belonging to? In which class it is belonging to? Anyone? At least guess. I always tell you that I want, like, the interaction should be two-way, not one side only. I shouldn't be only speaking. It takes a lot of time to prepare the lecture as well. I want that you should participate. It shouldn't be like only I am speaking. I also don't want that your time should be wasted after attending my class. Come on, let's try. Let's try both. As I told you, if suppose X is there and the probability of this G is basically output, the output is in K class, if X is given, it is higher than the probability that it is in L class, which means that obviously the X is lying in the class K. If it's the other side, it means that the class X is lying in the class L. I'm asking the simple question, if it's equal, then in which class it is lying? Is it in class K? Is it in class L? Or where is it?
Equal probability.
Equal probability. Where is it? Is it in class K? This X, is it in class L or where? You are right that it's equal probability.
So
Where is
class
it?
K, you mentioned it is output. So class L is
Also output. There are two classes.
okay. Both
Uh,
are output.
Both are
Are
output.
the classes not defined?
Hmm?
Are the classes then not defined properly?
No. They are defined. I'm saying that, okay, if probability of X lying in class K is more, which means that X is lying in class K. If probability of X lying in class L is more, which means it is in class L. Now, if the probability is equal, then
We may need one more maybe measurement to find out.
okay. Okay. What others think about it? Can I say it lies on decision boundary itself? Does it make sense? Come on.
Yes.
What about others?
Yes.
Yes.
Yes, ma'am.
Now, what I'm saying is, if how we do is like if the majority points in the training were in the class K, I was saying that okay, in testing, the probability was that the class K is having more points, this X points. So it will lie in class K. When I said they are in L class, now what I figured out, they are equal. Now the probability of suppose five, I have 10 points, five are lying in class K and five are lying in class L. So 5/10 and 5/10, that is 0.5 probability, both are having, which means that it can't lie in class K as well as it can't lie in class L. They are lying on decision boundary itself. Any doubt?
No.
No, ma'am.
So, now, obviously, if it's the case, then log of, if they are equal, like probability of G is equal to K, given X is equal to X, divide by probability of G is equal to L, X is equal to X, as I think Gaurav told, that log 1 it will be. Obviously, it will be log 1 because they are equal, the probabilities are equal, and it is equal to 0. The log likelihood. When it is in decision boundary case. And when is decision boundary case? When they both are equal. Then this log likelihood is 0. Now, what are the parameters we have to solve in normal distribution? When we talk about normal distribution, we are saying that we have taken the assumption that they are normal distribution. And when it is normal distribution, we have mean, obviously the variance it is, and pi. What mean variance, we know that this is related to Gaussian distribution, this bell shaped. It is having some mean, it is having some variance and all. This pi means, anyone can tell me? We have discussed in the last lecture, I think so. Okay, maybe I'll go again and I'll tell you. This pi k. What is the probability of G is equal to K? That is basically pi k, because it's a Bayesian rule. Fk is basically, I'll write again this equation so that whosoever has forgot, you can revise this, what I'm trying to say, just to have a link. So what is this equation? Let's try to understand once again, though we have discussed in last class, but still to have a connect between the things, let's try to understand it. So Fk of x here is, so if I normally write probability of G is equal to K given X is equal to X, the base rule. What is base rule? Anyone can tell me if I'll normally write? Yes, come on. What is base rule? Come on, come on.
Probability of x given g,
Hmm.
probability of x by probability of total probability.
Total probability or
It is
probability?
g.
Oh, wait a second. Sorry. Probability of G over probability of
Sorry.
H. So this is total probability. Okay. So here we can replace by total probability also. Okay, I'll come to the things. Now here what we are saying is let Fk of x is equal to probability of x is equal to x and given G is equal to K, which means this one, this is equal to Fk of x. Let us denote it by Fk of x, or I can say that this is class condition density. I also told you, like, okay, let us take it as Fk of x. So I have replaced this with Fk of x. I have replaced this, what is the probability of G is equal to K as pi k. And this is basically the total probability. Total probability is like if I am writing, this is a total probability formula. So if I have to write probability of X, I can write it as probability of X given Y is equal to K into probability of Y is equal to K. Any doubt? If you are having any confusion in total probability formula, yes, Mayank, you are correct. I didn't saw your message. Still, your mic is not there, or you are able to speak. No. Okay. So, okay. So this is the total probability formula we have done. Okay, we have replaced. Okay. So now I'm basically replacing it with this pi x with this. So what is this? If I see this p of x given j, I have replaced with fk of x. Okay, fine. Pg is equal, probability of g is equal to k. That is basically pi k. Fine. Now probability of x I'm replacing with total probability formula. So similarly here, okay, rather than y, I'll write g here. I'm denoting y as basically output as g rather than y. I'm making the same notations as professor, so you shouldn't get any confusion. So the same thing, similar to this. So here, what is it? Because it's L, so I'm writing denominator we are taking as L, FL, and the probability of G is equal to K, similar to that. That is why I'm writing pi L and summation of L, just denoting by L, nothing else. The same thing we have written, the base rule basically. So this we have already discussed in the last lecture. And now I just wrote it so that there shouldn't be any confusion and there should be a link there. So any doubts here? Should we proceed? This was already discussed, though. Again, I'll ask any doubts.
No, ma'am.
So, okay. So, what are the parameters we're trying to find? Mu, sigma, which are obviously we have to find it for the Gaussian distribution, these two parameters, as well as pi. Also, we don't know here. Pi, what does it mean? What is the probability of k? G is equal to k. If I think what is the probability of G is equal to K, which means what is the probability that the output is lying in the K class. So this is a simple, like I'll calculate how many number of data points belong to K class. When I'm having the number of data points, I'll say, okay, how many of them are belonging to K class divided by how many total number of data points are there. This is just a fraction. This is straightforward only. We'll come to this. So these are the three parameters. So now, okay. And we have also seen that for decision boundary, this log likelihood will be equal to 0. This we have seen. Now coming to the normal, which is basically not the decision boundary. I'll take the log here, probability of G is equal to K. I'll take the log for both of them. This equation, I'll take the log. Now you will tell me how I have come to this equation. So from this equation, how I came to this one? Think. As discussed, we'll do the MCQs, don't worry. Someone has given me a good suggestion last time. So after completing this LDA, we'll go to MCQs, then we'll jump to Perceptron and SVM, then we'll again do the MCQs of them. Yes, come on. How we came to, okay, I'll write it. From equation 1, okay. From equation 1 to equation 2. I told you we have taken log. What else we have done? Like how we have taken? Just simple, like so you should know from how we are moving from first step to the second step. I'm just asking you that. Come on, come on. Let's try. So probability of x given j is X given G is, this is Fk of X. This is Fk of X. That is what I have mentioned. Okay. Or let's come from this. Log Fk of, leave this, sorry. Let's come from this. So, log of, sorry. So, log of Fk of X into log of pi k. What I'm doing is log of Fk of X into pi k. And when I'm opening, okay, I'll write again. Wait a second. Divided by this. Okay, maybe I'll open it and I'll write how I can. Okay, k of X into pi k over log of summation FL divided by the reference that FL class, that was log likelihood. This is the log likelihood. The same thing, log of FL of X into pi L over log of summation of FLX pi. So this and this denominator, because of the sum, they are basically cancelled. We have log Fk of X into pi k into log FL of X into pi L. When I'm writing log A into B, I can write log A plus log B, which is equal to log Fk of X plus log pi k. Here also log FL of X plus log pi L. Fine. Any doubts? How we come up with this second equation? I have derived. Nothing, no derivation, nothing is it. Just what I have done, taken the log, denominators of both of them cancelled, applied this. So just substituted this value here and this value here also. So denominators were same because there's sum of them. So they are total probability of X basically. If I'll write simple probability of X, which will be same in both of the cases. The difference is here, na? X is same. The probability of X is same. So Fk of X into Pk divided by Fk of X into pi L. Just log of them. So log A into B was log A plus log. Any doubt? Should we proceed? Yes, come on, class. Yes.
Yes, we can
Division
proceed.
is
Okay. Yes, Suma.
log fkx plus log pi r divided the whole one, right?
Hmm.
Okay.
I didn't
But
get it. Can you repeat like what you're asking?
I'm asking that log fkx by log flx plus this one. Two fractions different.
Log A into B. What I'm writing is log A plus log B.
That one is
This
right. Okay, yeah. Yes,
fine.
yes. I got now. Yeah, yeah. Now fine.
Yes, Mayank. Lower term, basically it's not separated. I shouldn't write it as separated. Fine, Mayank. So, one more thing. Now we know what is Fk. Let's again go to the last lecture and see what was f of x. Multivariate Gaussian formula. We did in last class. Do you want me to repeat or we should proceed? Yes, come on.
No,
Do
ma'am,
you?
this is a memorization thing, right? We can't
Yeah.
really derive it again. So we can
Uh,
just...
So, this is a multivariate Gaussian formula. Just I'll write it. Intuition, this is a normalization term denominator, and this is Smanel obvious distance basically, in which they are considering the uh, covariance also basically. So now this is multivariate Gaussian. I am just substituting this fk value there. When I'll do, again you'll see that this 2 pi will basically get cancelled. Wait a second, maybe mm, just 1 minute. Let me check. I was in the impression they are basically separated. 1 minute. Okay. If I take this term, that's what, wait a second. I was taking them as separated only. Let me check. Yes, ma'am, you have also written they are separated. How? That's what I'm thinking why I did so. 1 minute. A plus log B. Yes, come on. Anyone? I'll write and then I'll come to that. Wait a second. Now, what is log fk of x minus log fl of x? Come on, come on. Anyone can explain? Ma'am, lower term has been separated log fk over log fl. Why it's separated? That's what I'm asking. Log fk over log fl. Why it's separated? Why it's not the same? Actually, I'm also getting confused. Like, as she pointed me now only, I also got confused why it's like this.
It is separated in the classes also, but never explain why it was separated.
I notice now only like I have derived this. I notice now only like why separated because when she pointed out very nicely like why because it should be the same only. That's what I'm also getting confused now. Yes, anyone? Okay, maybe I'll come up with this like in the next lecture why we are because if I'll take it not separated, then whole this thing we can't derive. That's what I'm also having confusion right now.
Technically, if you take a log of everything, it'll become a plus minus, and then you just rewrite it. That's it. That's what I think.
One minute.
It's log of f of k plus log of pi of k minus log of f of l minus log of pi of e, and then you just rearrange it and rewrite it.
Okay, that will be the same you are saying.
Yes.
Okay. Let's try. You're saying this, and then let's take it.
No, if you take if you go up the one where you wrote just beside the
Okay.
left of log a b.
Okay, you're saying let's take log a minus log b first, and then just open the
So
bracket.
imagine, let's take it this way: log of a into b,
Hmm.
divided by log of c into d.
You're saying log ab minus log cd,
So it'll become log A plus log B because they're multiplied, right?
Hmm.
Log C minus log D. And then what you do is if you rewrite it, then it'll be log A by log C plus log B by log D.
Exactly. You're correct. I suddenly got confused. Thank you so much. Huh. Exactly. So we can write like this. As yes, thank you for helping me out. I was also getting confused for a time, like how it happened. So absolutely correct. So when I'm saying log AB over log CD divided by log CD, I can simply write log AB minus log CD. And when I open it, so I can basically write it differently rather than taking like
Ma'am, sorry to interrupt, but the denominator, it will be like log C, log D, or kind of like that, right?
what?
I don't know how to explain it, but the
Okay.
denominator, you have mentioned only log C plus log D. You have separated it, but it should be together, right?
Wait a second. When I'm writing like this, wait a second. When I'm writing like this, I can take this term. I can write log a over log a over.
Okay, got it, ma'am. Sorry, yeah, thank you.
Fine now. Is it fine now, everyone?
Yeah.
So yes, so we have, that is why we have written. Suddenly, I also got confused. Sorry for the confusion for the whole class. I'm so sorry. So we have basically written like this. Just separated it out, and then we have basically told that okay, FK. Mayank is asking something. We should take log one more time, ma'am. How is it possible log AB over log CD? Log AB over log CD. This is what we are doing now. Log this over log this. That is what we are doing. This is like log AB over CD is equal to log AB minus log CD. That's what. It's actually log AB over CD, not log both sides. It's like log overall. It's like this. So that's why log AB minus log CD, and then we are opening it. Fine, Mayank? Should we proceed now? Any confusion still now? Okay. So FK, we have written it. And then now we are basically substituting trying to substitute the values of FK. Okay. So let's try to do that. So what are the values? Okay. One more thing. When I have this log FK over log FL, when I'll basically do this 1 over, this is the same term which will be there. Only the difference is basically in this XK, XL and all these. So difference is in this part. Denominators will again cancelled here. So only numerators will left. So if numerators will left, so how it will be? Let's see. So log of this E, obviously again this will be cancelled out, and E over X. So what is this value? Can someone tell me? Log E power X.
Mix.
Yes. So here again have this term only. Denominators will be cancelled out. So I can write this term minus half x minus mu k for the k term, sigma inverse x minus mu k for the L term, L think, minus half x minus mu L transpose sigma inverse x minus mu L. Fine. Any doubt? Any doubt? Mayank, Yashwant, Gaurav, Medha.
No.
Don't think I'm taking someone's
No,
name, or I'm taking randomly only. So, okay. Now, the next thing is let's see one thing, like when I write this x minus mu k transpose sigma inverse x minus mu k, I can write it as x transpose sigma inverse x. Any idea how I'm writing? Though I'm back engineering, like first writing the equation and then telling you how, so that you should also uh, try at least, like how we came. Like in the class also they have, I think, written directly only how we came up with this.
They're just multiplying the three, no?
So x transpose sigma inverse x. How this minus 2? So basically it was scalar in nature. This mu k, uh, wait a second, mu k transpose sigma inverse x as well as, wait a second, I'll write in the simple words so that you can understand.
My understanding is half is always multiplied because this half is always multiplied because in the end we are going to take a differentiation. That's why there are square terms over there.
Okay. No, just it's opening the brackets. If I'll say this is the same thing, just I'm writing so that it should be easier to you to understand. This is the same only, just those values are there. So these are basically scalar in nature. So that's why I'm writing here minus 2b transpose ma. You got it, like because A transpose MB will be equal to B transpose MA because they're scalar in nature. Similarly, here also, the terms are scalar in nature. That's why this two came. Nothing else. Nothing
What
else.
is sigma inverse? We have sigma inverse over here. Is that what is a sigma inverse?
Mhm. Got it?
Like I know what's sigma, then sigma inverse. Is it some other thing? Is it
We
epsilon or is it sigma?
It's sigma inverse only, covariance matrix inverse only. Nothing else.
Okay. Okay.
We have done this formula. This is the formula which you said that okay. Um, this is the same multivariate Gaussian formula. Nothing else. We are having here. So just this is the part which we are doing here. Just it was scalar. That's why it was minus 2. Nothing else. So the same thing, A transpose MA, which means suppose this is X transpose sigma inverse X, the same thing, minus 2B transpose MA, which means minus 2 mu K transpose sigma inverse X, plus B transpose MB, mu K transpose sigma inverse mu K. Nothing else, just like opening the brackets. Okay. Similarly, I can write it as the other term also as x minus mu L transpose sigma inverse x minus mu L as same x transpose sigma inverse x minus 2 mu L sigma inverse x plus mu L transpose sigma inverse x. Oh, sorry, mu L. Similarly. Now let's substitute it back. I have written these terms basically. Now substitute it back into log f over fl of x, fl of x, not so, which is here minus half. I'll take it as common here. Minus half. This term and this term is there. This term, we saw that which is equal to this term, and this term equal to this term. Nothing but only mu k instead of mu k, mu l is there. So let's write x transpose sigma inverse x minus 2 mu k transpose sigma inverse x plus mu k sigma inverse mu k. Similarly, half x transpose sigma inverse x minus 2 mu L transpose sigma inverse x plus mu L sigma inverse mu L. Any doubt? What I have done here, minus half, this term basically got substituted by this term which we have written, just opening the brackets, and we have just written the other term which I have written, and this mu L converted to this. That is what we have done. Any doubt? And one more thing. I think, okay, fine. Any doubt? Should we proceed?
Yes, ma'am.
So, anything which is, okay. Can I say these terms are basically getting cutted off? Like,
이티엘에 돼.
yes.
이비드라. 이쪽도 아니지.
Any doubts? Okay. So these terms are getting we are cutting it off. They are the same, plus and minus. The terms now which are left is the other two terms, this one as well as this one. Am I right? So if I talk about these terms, let's write it. Mu k minus mu L, taking it common, sigma inverse x. Half into 2, basically it's 1. So that's why we are left with mu k minus mu L transpose sigma inverse x. Now the third term, this one. So minus half mu k sigma inverse mu k. Here obviously it was plus, so now it's like minus minus plus. That's why sigma inverse mu L. Fine. Any doubt? Come on. Come on, come on.
Ma'am, would you please walk through once more the part after you introduce a Gaussian in place of f of k? Because that part is model.
This one is fine, na? Fk. From here you are saying?
Yes, this is where, yes.
Okay, let's see. So what we have done, log a minus log b. This was basically get cancelled out because it was fk over fl. Both were having the same denominator, so it got cancelled out. So log e raised to power x, which is equal to x only. So this terms we were having now. So this term, for this basically we are having mu k. For both of them, x minus mu k, as we know that mean are not same in this case, whereas sigma is same in this case. Am I correct by saying this? So mu k and mu l, they are different for different classes, but that is what now we are doing. Half minus half x minus mu k sigma inverse mu k. That is what I have written by taking log. And minus log fl of x. So the same thing, minus half this log of e basically is equal to 1. So that's why minus half x minus mu L transpose, x minus mu L transpose sigma inverse x minus mu L. Is it clear this point? Should we proceed? This point is clear, Gaurav?
Yes, ma'am.
You can ask me if it's not clear. Is it fine?
No, it's fine, ma'am. It's fine.
Ah.
It's
So, okay. Oh, this was only taking the log, and then the denominators were getting cancelled out. Now, what I did is x minus mu k transpose sigma inverse x minus mu k transpose. I have just opened the brackets and written like this. For understanding, I just took a minus b transpose x is equal to a, mu k is equal to b, sigma inverse a minus b. When I opened the brackets, it was something like this. A transpose MBA, MA minus 2B transpose MA plus B transpose MB. Because these were scalar terms, so that's why A transpose MB is equal to B transpose MA. So similarly, I wrote in the place of A, I wrote it as x. In the place of B, I wrote it as mu k, and in place of M, I wrote it as sigma inverse. Same thing, just open the brackets. So I got the value x transpose sigma inverse minus 2 mu L transpose sigma inverse x plus mu L transpose sigma inverse mu L. Fine? Or mu k. In the k case, mu k, and in the L case, mu L. Fine? Fine,
Yes,
Gaurav? Fine, others? So then what we did is, then we again, now we have taken, okay, these were the values. Now just plug in the values of this. Only the half was missing. So minus half this mu k value, minus plus my half minus half this value. Fine. So it was minus minus, that's why it's plus. Fine. Fine till now.
Yes.
So okay, this is the case now. This value and this values were same. This was only minus half, this was plus half, so they get cancelled out. Fine. Now I took this value. This is minus half multiplied by 2 mu k transpose sigma inverse x. So this 2 and 2 get cancelled out. So I have mu k sigma inverse x, as well as, if I'll see here the same value, this is mu L sigma inverse x. So that's what I took it out. And if I talk about the third value, this is basically this minus half will be considered here. This minus minus get cancelled out, that's why it's plus. And if I talk about this value, this is minus half mu k sigma inverse mu k minus half mu L sigma inverse mu L. Fine? Fine now? Or any doubt, Gaurav?
No, ma'am, no doubts.
What about others?
no.
Okay. So one more thing, as we have discussed earlier only, I think mu k transpose sigma inverse. Wait a second. Mu k transpose sigma inverse x. Talking about this. This is basically scalar in nature, so I can write it as. Okay, one more thing. If I'm writing scalar, you have to see the dimensions and see that how it's scalar. I'm not writing again and again the dimensions and all of everything. You have to see. If again you get the doubt, like, ma'am, how it's scalar, I'm not telling you like how it's scalar. When you'll multiply, you will get that the dimension is equal to 1. I have already mentioned the in earlier lecture what is the dimensions of mu k sigma inverse x and all. So you have to see that how it's scalar. Again, if you get the doubt, mail me, ask me. Okay, so these are scalars, so I can write it like this also. That is what. So here I can replace this mu k transpose sigma inverse x by x transpose sigma inverse mu k minus mu L. Because when I'll take the transpose, why I write like this, A transpose is equal to A only in the scalar case. If I take scalar means I am taking a single value. 1 transpose is equal to 1, 2 transpose is equal to 2. That's why it is having one dimension only. When I'll take this transpose, this will go like mu k transpose sigma inverse x. So how it will be, we'll write from right to left, x transpose sigma inverse mu k when I'll take the transpose. So the scalar's transpose is equal to the number itself. That's why I can rewrite it like this as well. Fine here. This point is fine. Should we proceed?
Yes.
So x transpose sigma inverse minus half, again mu k sigma inverse mu k minus mu L sigma inverse mu L. Now again I can write it like this. I can write this as This term has. Can you say how? Like, can you open these brackets and see whether it's the same? Anyone? If I'll write like mu k, I'll open the bracket, mu k transpose sigma inverse mu k plus mu k transpose sigma inverse mu l plus mu l transpose sigma inverse mu k minus mu l transpose sigma inverse mu k. So sigma inverse, basically it's symmetric in nature.
What's that?
Yes, any doubt? So sigma inverse is symmetric in nature. So basically they are, again, the transpose is equal to the same only. So that's why this these are equal. So we came up with this equation. Sorry. So we came up with this. Mu k plus mu l transpose sigma inverse mu k minus mu l. When we opened it, mu k transpose sigma inverse mu k minus mu l transpose sigma inverse mu l. From this to this. Any doubt? Again, I should explain. So what I'm saying is, again, let's see. So what I'm saying is mu k plus mu l transpose sigma inverse. I was here. Mu k transpose sigma inverse mu k minus mu l transpose sigma inverse mu l. Wait a second. Am I doing something? We came from here to here, sorry. Can someone explain what I have done? Come on. How I have cancelled and how the things are like. Should I again go through this? Or you got it? Come on.
I think you should continue. This is difficult. We'll go through it once more maybe.
I'll tell you. Nothing. Don't worry. Don't worry. I'll tell you. From where you are getting doubt, ask me. It's fine. It's nothing difficult. It's
No, it's just that there's it's not a, there's no doubt. There's a huge volume, so that volume is
Getting.
volume of information is just too much. It'll take a while to process it. That's all I'm saying.
Okay. So just quick go through. Like we were here like mu k. 1 minute. I'll come this. So we were here. I told you we'll cancel these terms. We have written mu k transpose sigma inverse. So I can also write x transpose sigma inverse mu k because this is scalar in nature. So I can write it like this. Then we came up with the third term, which was mu l, this one, mu k sigma inverse mu k and mu l sigma inverse mu l. So what I'm writing I'm writing it as this thing. So how I'm writing it as, I just opened the brackets and I showed you this term is basically equal to this only because sigma is basically symmetric in nature and this will basically be cancelled out. The transpose will be equal. So that's why I am having this term only. So these are basically equal. When I'm opening it, I'm getting this term. So that is what is the motive here to tell you. Now, talking about the discriminant function, which means if first I'll write whole equation, what log pi q over pi l as you can see that we were solving log fq over fx and this was log pi q over pi l, which we'll look here. Now, what are the things left here? Log pi q over pi l minus half mu k plus mu L transpose. That is what now we have done. Sigma inverse mu k minus mu L. And the second term was X transpose sigma inverse mu k minus mu L. This is the whole log likelihood. Now the discriminant function, if I talk about the k thing only, discriminant function of k only, then I'll only take this k things, or basically it's the same without taking the L things. Second is scalar, that is equal to transpose, then it is cancelled by third term. Mayank, are you asking something? Or you were answering, I didn't check. So just taking the k terms, if I got the score of the
Ma'am,
class.
ma'am,
Yes.
how did this delta term came? Delta k, x k.
This is basically discriminant term. Okay, answering. Okay, sorry, I didn't check earlier. What I'm saying is this discriminant term, what is it? Like this is the score of the k. When I'm talking about only k terms here, this is like, this is k and L terms here. This is log pi k over pi L. Now, if I talk about only this k terms, what is it when I'll see that X transpose sigma inverse mu k minus half sigma inverse. Okay, 1 minute. Minus half, oh sorry, I have written, forgot to write mu k transpose sigma inverse mu k plus this log pi k. This is only the k term, only the score of class k. This was whole log likelihood where I was considering pi k and pi L. When I have to consider only k, then I'm only talking about the k terms here. And now what is the main motive here? I have to pick that class which will give me the highest score, which will give me this highest log likelihood. That is what we usually do. I have to pick which will give me the highest log likelihood. Log x. If I talk about log this delta k, which will give me the highest, the k which will give me the highest one. That is what I have to find out. Pick that k that will give me the highest score. Pick that class that will give me the highest score. Any doubts?
No, ma'am.
What about others? Is it going above the head? Is it like too mathy? Once you'll go through it, you'll find it fine. Maybe the scalar terms and all, you have once have to check the dimensions and all, you can cut it off directly. Okay, and what were the other things? We have discussed that pi k was simple, the number of data points that belong to class k over the total number of data points, that was pi k. Mu k, what is mu k mean?
The total, is it covariance matrix?
No, it's mean. Mu k means mean.
Okay, then the total, the average.
Average of all features of class k. Now I have founded the class k, which is the max k, which class there is there. Now I'll average all the features of that class k. That will basically be the mean. Like I'll pick all the data points. I'll tell you what will be now mu k. I'll pick all the data points for which class was k from training data, and I'll find the center of them. That is basically the mean. So basically average all the features of the class k here. Or what is the sigma here? Usually it's like the variance thing. It's like Divide by n minus 1. I'm not taking that divide thing. I'll write, then I'll explain. Maybe let's write n minus k, because it's like this is the mean na, usually. Yes, can someone explain me? So here, what I'm taking, mean of the class K only. I'm not taking the mean of overall. Not whole mean. So I'm taking of the class K only all the points which are belonging to that and adding up all the classes here. That is basically the variance here. Again, let's go through just a quick revision what we have done in LDA, how it do, and now we'll also see the another view, that is the Fisher view. That's more important actually. So what we did is nothing. We just only we have solved the log likelihood, the same we have log odds, basically the same way we have done in the logistic regression, the same way we are doing in LDA here. Nothing else. We have here assumed that okay, there is a Gaussian distribution, and then we took the reference like one K class and the other is the L class. That is what we are doing here, and then we took the log as we have done it earlier, just solved this log A plus log B, nothing else, and then we came up with the solution. This was the math part, and then we came up what will be the pi k value, what will be the when we find out the k thing, like which is the k part, like which k will be the highest one, which will give which class will be the highest one. So we'll pick up all the data points from the all classes and then calculate the mean as well as the variance. That is the main point. Now the other point, other LD, another view of LD, that's more important. The intuition behind is more important. Can someone tell me that Fisher criterion or the other view? Are you getting it, or it's like tough to understand? Give me the feedback so that I should know at least.
We'll go through it once, ma'am. We'll go through it once. It's a lot of.
What about others?
Yes, ma'am, it's difficult, but we'll go through it and maybe we'll be able to understand more.
Any doubt till now, like you're not able to understand, or what is the issue going on? Is it like too mathy, so it's like tough for you guys, like you have
Too
to.
many terms. There's just too many terms. We just need to go through it little by little.
Okay.
We can understand we can follow it. Like for example, why half is coming, because it's e to the power and uh, so we till that it's understandable. But then we'll understand it once we go through it ourselves, but slower next time. That's. But yes, ma'am, we'll go through it ourselves. We should carry on, I think.
Okay. Okay. Mayank, you are right. Like between the class, within the class, that is what. So another view of LDA is basically within the class variance minimize and between the class variance we have to maximize. So what do you mean by this? Like within the class, I have written some terms. Like, can someone explain me what I mean to say? I'm writing something. What I'm trying to say, can someone tell me? And what does it mean?
For me, technically, if it's in one line, then we are trying to consolidate each class's information around its mean, and we
Hmm?
are trying to separate both means apart so that it's easier
Ah,
to discern between the two in the
exactly.
same line.
Can I say if I think about like clustering, they are like tightly clustered together, whereas from the other class they are far away? That is our main motive. If there are two classes, the with the points within the class should be tightly together, whereas from the other class it should be far away. So our main motive is maximize the class variance within the class, minimize between the class. Sorry, minimize between within the class and maximize uh, between the class. Am I correct? So mean of them, as you told me, they should be as spread as apart. Whereas if I talk about between the class, like within the class, they should be as compact. Each class should be tight and as compact as possible. Fine. Okay, a question arises, why between the class, why we want to achieve like this? Why we want to achieve that two classes should be far away and all? Come on. Come on, come on. Yes, Megha. Yes, Mayank, Gaurav, Yashwant, Uma. Come on. Let's give a try.
Is it because to have a clear definition of a class?
To have a clear definition of class. Somewhat, yes. So, can I say that uh, there should be less chance of overlap between the class? If between the class variance will be maximized, they'll be far apart. The chances of overlap between the classes or misclassification, it will be basically minimized by doing so. Am I correct
Yes.
about this? So, uh, let's try to do. So here we are going to take the projected mean and all. Let's write it as y is equal to w transpose x. What do you mean by this? Y is equal to w transpose x? It's simple. Mx plus c, like simple, the line here. I'll first write it out and then explain. Can someone tell me what I have written? Or maybe I'll write the other term as well. Yes, can someone explain me okay. Fully classified the projection of y into dimension of x. Exactly, this y is equal to w transpose x, as said by Mayank. Yes, exactly. It's the projection of y into x onto the direction of x. So what I'm saying is M1 and M2 bar, they are the means of class 1 and 2. Now please see the terms so that you shouldn't be confused when I'll use the terms again. M1 bar, M2 bar, let it be the like means of them. And then M1, M2, if I'll not have the bar there, then it's like the projected mean. And what is the projected mean? How I'm writing? As I'm projecting on W line, so that's why it's like W transpose into MK bar. The mean is basically getting projected, and that's why I'm writing as MK. So if I'm saying M1, which means that is the projected mean of class 1. Now, can someone tell me what is optimization thing, what I have written? Yes. We have, I've told you something, the intuition behind it. Can you relate and can you now tell me? I've told you some intuition here. Now, can you relate with that and tell me what I'm trying to do here is what is M2 bar? What is M1 bar? I think someone told me earlier also. M2 bar, M2 bar, M1 bar is basically the mean. What is W transpose M2 bar, M1 bar? That is basically the projection. Now, what I'm doing is can I say the projected distance between the class mean is basically maximized? I'm basically trying to maximize the distance between the mean, class mean. That is what my main motive is. I think Gaurav only told me by maximizing the distance. That is what
Yes.
I'm trying to do. Trying to maximize the distance between the projected mean, whereas I'm taking some. This is a constraint such that constraint so that it shouldn't be like it shouldn't go larger and larger. We don't get it. We don't want it to be unbounded. So that's why a constraint is there. So if I talk about within class variance, this is like between, okay, or I'll write that W is basically one more thing. What does projection mean? Can I say the shadow? If in layman language, this is like the shadow here. That is basically the projection here. And what we want that if we are having the two Gaussian things, their shadow, their mean, they should be basically far away. That is what is our main motive here. That is what we are trying to say here. And now what we are saying is like we'll fix a threshold between them. Okay, leave that. For now, let's try to understand like this. Why we are trying to do this? So that they shouldn't get overlap. As I told you that they shouldn't get misclassified. In other sense, we can say these projected means shouldn't get overlap. If they'll not get overlap, the chances of misclassification will be reduced. Does it make sense? Yes,
Yes.
come on.
No, I understood the argument max W transpose by what such that pardon such that WH square is equal to what? Such that the projection square sum of projection square is equal to
One. It's just a constraint on W so that it shouldn't go as large as possible. It shouldn't be unbounded. So it's a constraint taken.
okay.
So now one more thing is there within class variance. This we are saying, okay, they should be far away, the between class variance. Now talking about within class variance. I'll write, then I'll explain. Can someone tell me what I have written? Try to understand it. What is W transpose Xi? Projected point. What is W transpose MK bar? Projected class mean. What is the difference? The distance between them. What is variance? How we write it? X minus mu square. Is it the same? Come on. Just the projected one. Projected variance one. Can I say? This is within class variance. We write it like this only, na? Over divide by n minus 1. Leave that for now. Usually we write like this only, na? The distance. Come on. So this is the formula, na? The x point with the mean. How much is the distance between them? That is what I'm trying to do. This is the projected x. This is the projected mean, basically. Which means projected means this is x. This is the shadow of x. I'm projecting on W line. So when I do it, now it becomes, this point becomes WX. Or because of the W transpose, because of the dimensions thing. Fine. Come on. Say yes or no at least.
Yes, yes, ma'am. Yes, ma'am.
What about others?
Yes, ma'am.
Just one question: how are we minimizing within class variance again? Okay, X is the point, and MK is the projection.
No. What X is basically the point. Okay. This is W transpose. When we project it, project means shadow. When we are projecting it to some line, which is W, so it becomes W transpose X.
So I'll tell my question again. I understood why. Uh, so, for example, for optimization, when you're trying to increase a class, you're writing argmax. I understood, but which part over here is trying to say that you're reducing
I'll come to that.
variance?
Just I'm writing it. I'll come to that. You are saying that I'm just writing it. I'm not reducing. I'm not writing min or something. I'll come to that. Don't worry. Don't worry. So this is how I'm writing it. Just now, if I write about this was simple delta K square. I'll come to these things. So one more thing. Okay, this is delta. Now, if I talk about the overall class, like within class variance, if I have two classes, I can write this plus this. Can I write like this? So K is only, this was class 1, this is class 2. So this is within class variance. The class variance of 1 plus variance of class, within class variance of for whole data set. So now what I want is, according to Fisher criterion, this is the formula which he has given, but how? Let's try to understand. Can someone tell me what I have written?
Mean square by variance square.
Can I say this is the between class variance? You told me, Gaurav, you only told me that the difference between the mean should be, that is between class variance. Am I correct?
Yes.
Yes. This, we saw that this is within class variance for overall data set. Yes?
Yes. Yes.
So can I say this Fisher criterion, what is it? The ratio of between class variance divided by within class variance.
Okay, and
Of
we
class.
increased
And
between class variance
I'll,
already.
huh? Huh? I'll come to all your questions. First, this formula is fine. What about others? Yes, come on. Yes, Abdullah, Narendra, Raghuvanshi, Jayashri, Jyoti, GVSR, yes. Kirtana, Megha, Sachin, Sneh, Yashwant, Uma, Trishay, yes, come on. Satyarani, Saranya, yes, come on, Pritam. Mayank, is it fine? Give me thumbs up if you have got this. If you haven't got this, ask me. There can be two situations. What is within?
Yes, ma'am.
Okay. Yashwant is asking what is within class mean. Can someone explain him? Within class means. Okay. Actually, what we are saying is within class, what we are saying is we are trying to, our main motive in LDA is basically to try to reduce the within class variance and to maximize the between class variance. So within class variance, we are saying that is this thing, variance, which means that difference between this data point as well as the mean thing. So that's what we are saying, the projected data point and the projected mean. That is what this square of it, that is what this is basically the within class variance. So this basically is the within class variance, and this is basically the between class variance. This is the Fisher criterion, the way he is looking to LDA. This was LDA was given by him only, and this is how he is looking, and he's saying he has given this formula, and this is what between and within class variance means. Is it fine, Yashwant? Okay.
Yes, ma'am.
Now, let's come to first term, m2 minus m1 square. Can I write like this? Come on. Yes, can I write like this? What is M2 projected mean? How can I write the projected mean? I told you M2 is projected mean, M2 bar is the original mean.
Yes, ma'am.
So,
Yes, ma'am.
yes, and W transpose M2 bar is M2 only. W transpose M1 bar is M1 only. So, I'm writing like this. When open the bracket, M2 bar minus M bar bar into W. I can write like this. Nothing. Sorry. M2 bar minus M1 bar transpose into W transpose. W because transpose is taken. Fine. When I'm writing A square, it's like A transpose A, the same thing I'm doing. Fine. Matrix. So this term here, basically, this is basically, I'm saying it as SP. SP means between class scatter. That is what M2 bar minus M bar and M1 bar means, basically between class scatter. How much is the difference between them? That is what. So we are basically terming it as SP, and then we are writing it as W transpose SP W. Fine. Nothing rocket science. Come on. Fine.
Yes.
Now, similarly, the other term, delta K square. The same thing I have written earlier, which I have explained you, W transpose Xi minus W transpose Mk, just taken W transpose as formula. Similarly, can I write and this is SW, which is equal to S1 plus S2, like whatever that variance is there, Xi minus Mk, whatever, in whichever classes it's there, like S1, delta 1 plus delta 2, whatever. So this term, let's take it as SW. Is it fine? I mean to say SW
Yes,
is
ma'am.
sigma G is equal to 1, Xi minus M1 bar into Xi minus M bar transpose plus sigma G is equal to 2 Xi minus M2 bar into Xi minus M2 bar transpose. So basically,
Why is there W in the end after the X minus MK transpose into W?
then,
Okay, because W is squared as well.
square.
But then what are you dividing? That I'm not following.
So, I'm not dividing. I'm saying that this term, let us take it as SW.
Okay.
I know. Mm. SW, where SW is basically, as it is sum, so SW is basically this. As I told you that this is basically delta 1 plus delta 2, na? So this is the same thing, delta 1 plus delta 2. Delta 1 plus delta 2 variance, I told you na, that x minus the mean thing square. This is what we have the variance thing, na? Though I'm not taking this n minus 1, I'm not considering taking it as constant or ignoring this n minus 1. So taking the sum, this is basically the variance. So this I'm taking this part, I'm taking it as SW. Fine.
Yes, ma'am.
What about others? Please give thumbs up if you have understood. Just give me 2 minutes break. I'll have water and I'll come back. Meanwhile, okay. You guys are writing or you guys are just listening? First tell me. Tell me.
Writing.
Writing, na? So it's a good habit. Please do write. Otherwise, you'll not get anything. Like it will be just revise the part what I have told you about this Fisher criterion and everything. I'll just come in 1 minute, 2 minutes basically. Also writing. Yes, ma'am. Am I audible?
Yes, ma'am.
Let's proceed. So, till now we have done okay. What was just understood the terms. 1 minute. So, We are writing it as W transpose is BW divided by W transpose is WW. And we have to maximize this. Now, can you tell why maximize this? Like you were saying, na, like what we are doing, minimize, maximize. Now you can tell me. What is the upper term? What is the numerator term and what is the denominator term?
Numerator
Between
is
class scattered upon within class scattered.
So between class variance upon within class variance. So if I'll maximize this, what does it mean? Okay, let's see. So how we'll do, minimize or maximize, whatever we want to do, how we'll do when we have to do, how we do usually? Do we differentiate it? Between class variance, as you told, divide by within class variance.
The numerator should be bigger, right?
The numerators should be bigger. Na? Maximize. What we have to do, we have to increase the variance between the classes. We have to decrease the variance within the classes. That is what we have to do. Na? Does it make sense now? Yes, you are correct, Mayank. Derivative. Does it make sense now? We have to increase between the class and decrease within the class. Increase the gap between the class, tightly clustered it within the class. So that's why I'm maximizing. Exactly correct, as Mayank said, that we'll take the do the differentiation whenever we have to do the minimization, maximization from linear regression and all. We are seeing that how we are doing it. So let's differentiate it with respect to W. So numerator by denominator, differentiation, denominator square, W transpose is W square, whole square, writing denominator as it is, taking the numerator's derivative, it will be 2 SBW minus, writing numerator as it is, W transpose SBW, taking the derivative of the denominator, which is 2 SWW is equal to 0. That is what we do. Take the differentiation, equate it to 0. Fine. Any doubt in this differentiation? Fine. Should we proceed? Come on.
Yes, ma'am.
So, obviously denominator becomes 0 only. So SBW, 2 and 2 get, okay, wait a second. SWW is equal to SWW into W transpose SBW. 2 and 2 got cancelled out. And SBW is basically, SB is basically mu, I should write, no, I shouldn't write mu2. It should be M2 minus M1, M2 minus M1 transpose. Wait a second, it is. Sorry, bar. And if it's WSBW multiplied by W. So one more thing. We know that when we'll see that SWW is scalar. Please, these scalar terms, you have to verify how and all. I'm not going to now tell the dimensions. If you have any doubt, ask me, okay? Scalar. And now we are seeing that SBW is directly proportional to SWW. From here, we are seeing that. And we know that SBW, maybe I'm fast, I'll come again, is directly proportional to M2 bar minus M1 bar. Now we are only seeing, we are dropping the scalars, we are only seeing the directions here, how the things are going. If I multiply both of sides with wait a second. So if this is directly proportional, then I can say SWW is also directly proportional, because SBW is directly proportional to SWW. Fine. Come on. Come on, guys. Is it correct? Okay. Again, this derivative is correct. Differentiation is correct.
Yes, ma'am.
So is this equal? So can I say SBW is directly proportional to SWW? And I know that SBW is equal to M2 transpose minus M1 transpose. M2 minus M1, M2 bar minus M2 bar, M1 bar square, or this transpose. So they are also directly proportional. So if they are directly proportional, they are directly proportional. So it is also directly proportional to this. Am I correct by saying this?
Yes,
So if I multiply this both the terms by SW inverse, can I say? Now, can you tell me what does it mean? This is the final result. What does it mean? We did something, we came up with something, but like, what does it mean? This is separation between the means. That is what? What is this? SW. Can I say it is something with related with within class variance? Am I correct by saying this? Delta terms and all, SW. Now, what I'm saying is, when I'll increase this separation between the means, when I'll decrease this separation between the means, this will increase, and when I'll increase this will decrease. So, can someone tell me? Yes, Mayank is giving thumbs up. Can you tell me in chat, like, what do you get it from this, or anyone else?
You can increase from the first part. It's like if you can increase the variance between the classes, you'll increase the it's proportional to increase.
Actually, Gaurav, your voice is cutting. Your voice is cutting. Gaurav, your voice is cutting. We are unable to understand anything. Can you write in the chat, Gaurav, because we were unable to understand anything? Yes, what about others? Bad internet. Okay. Can you write in the chat? Yes, and who gave thumbs up? I think Mayank, you gave. Can you also write in the chat what you got it? I know you can't speak. So can you write in the chat? At least I suggested you can try from other device like mobile, or someone's laptop, mobile, or some other device, and then check is it working, or log in from other ID and try it, Mayank. So it's like within variance and separation between the mean, can I say they are itself inversely proportional to each other? So if the scatter is high, if the separation if the separation between the means is less, can I say the scatter will be high? Uh, like if I say the separation between the means is more, sorry, then can I say within the class variance will be less, and it will contribute, it will be lesser in and yes. So it will be basically they'll be basically compact in nature. That's what I'm trying to say here. The whole point of LDA was, okay, what we are trying to do is we are trying to the first line only. We are trying to minimize within the class variance and maximize the between the class variance. That is what is depicted here. That is what we are trying to do. So this is the same thing, just we are writing the equations and how we are trying to do, and what does it mean actually. Like m2 minus m1, what does it mean? That this is between the class variance. Like m2 is the mean of one, of projected mean of one class, m1 is the projected mean of the other class, and we are trying that they should be far apart. Whereas within the class variance, what do we want? That they should be close to each other. What is delta? What is the variance? Obviously we know that the variance is data point minus the mean here. So that is what we are doing here. Just we are doing the projected data point minus the projected mean, and then we are differentiating in order to maximize this and in order to calculate what is w. And then we got this term. We are basically talking only about the directions, only about, and ignoring the other terms to check like what do we what should be the w thing. Fine. Should we proceed to the other topic? How was LDA? Okay, let's try to solve the MCQs first before jumping to the other topic, so that if you're having the doubts also, it can be cleared by the. Okay, before this, what do you want? Should we try to first do this assignment thing, or should we jump to this MCQs, the extra MCQs?
MCQs.
Okay. Uh, do you want that assignment means the assignment MCQs? Do you want me to solve that? The assignment two, oh, sorry, assignment three MCQs.
Yes,
And
ma'am. Assignment also. Assignment is important.
okay. Wait a second. 1 minute. Let me logging in. Then I'll share the screen. The assignment stuff, like what are your feedback regarding the assignments?
Week 3, 4, 5. 4 and 5 are actually definitely.
I checked fourth. Fourth was, I think, not that tough. Maybe we'll do in the class, then we'll find out. Maybe it was experimentation. Okay, let's see. Week 3. Yes, Trishe, any doubt?
I had a question regarding assignment 5. Like, if you have missed something due to any, like, I don't know if you're the right person to ask, but if you have missed something regarding, because of medical issues, like, is it considered?
Okay, this is basically submitted. The results are out for week 5 or not?
I think they are, but like, I missed the assignment. I was not able to do it. I've
Maybe,
done week 6.
okay. Maybe you can mail them regarding that. I don't think so they'll
I
consider.
tried mailing them, so the response was like apparently that email ID which the mail does not like we have to post it on a forum. So I posted it on a forum about 2 days back. I haven't gotten any response. Like there's a discussion group.
I know about that. Okay.
So like if there's any other place I should
No, I
approach,
don't think
then
I don't think so. That is the only place. They'll only reply. It's not in my hands.
okay. But like, do they consider it generally or?
I don't think so. It will be tough. So it's like one assignment, it's fine, but do check the like other assignments. Do like take care of them. Don't try to miss them. I think what is the what is like the percentage of the assignment marks in the overall marks? Any idea?
I think it used to be 30%.
30%. It's fine. We have 12 assignments. Don't try to miss the other ones then.
Mm.
Though you can try at your end, but it's tough. Like, let's see.
Yeah, I've already posted it like on the forum 2 days back.
Uh,
So,
Again, you can mail them that I have posted and I didn't get the reply.
okay.
You can do that.
And like out of 12, how many assignments are considered?
All are considered. It's not like best. I think it's average. I
I
think.
read something about there being a best. I think it was like 10 or something. 10 assignments.
Okay. Maybe I'll check with someone and tell you
Okay.
next class. Okay, for a two-class problem using discriminant function, where is the separating hyperplane located? Anyone? Come on.
Delta 1 minus delta 2 has to be 0.
Delta 1 is equal to delta 2. So, exactly. So, how you'll solve this? I'll not tell you, like, I'll not solve. Can you tell me how you'll solve this? I have the similar problems in the other MCQ part. How you'll solve this? Anyone? Come on, come on. You have done this assignment? Yes, Mayank, Gaurav, Suma. Yes. What is the who asked me now? Trishay, yes.
Uh, we'd calculate the total probability of feature one if it's class A, or one if it's class B, and then it is feature of feature one if it's class A into number of class A's by total. So the total would be whatever's in the features.
So is it not like number of samples in class A over number of samples in class B? Prior probability.
Is with the total class.
Hmm.
There are 5 class A's divided by total of
Yes,
them.
yes, exactly, exactly. Total of them, that is 8. Yes, 5 by 8. Exactly. Mayank, you are also correct and you are also correct. Okay, what about third in three-class classification problem using I'm not asking about the answers, how you've got these answers. That's what I'm asking, so that you shouldn't have any doubt. So, to which class would this point be assigned? How you got this? 1, 2, 3. Yes, come on. This is very simple. Linear regression, output vectors of 3 data points are given to you. To which classes would these points be assigned? Come on, come on. Okay, let's consider first data points, 0.8, 0.3 minus 0.1. So which class? Which is having the highest probability, can I say? The maximum probability, which is having, that is what I told you now only, na, that okay, this class is having, we started with this LDA by having like, okay, if this class is having this highest more probability, then the point belongs to that class. If this class is having the more probability, then the point belongs to the other class. And if they're having all equal probability, then it's in the decision boundary. First is yes. Exactly, Mayank. So first is 0.8 because first is class 1 because point is 0.8, 0.3, minus 0.1, 0.8 is the maximum. In the second one, 0.6 is maximum, so class 2. And in third one, 0.7 is maximum, so class 3. Is it fine? That's what we discussed today in today's class also. Whichever will have the highest probability, that point will belong to that class only. And if they are equal, it is belonging to decision boundary. Okay, fourth. Any idea? It's basically d degrees greater than k minus 1. K minus 1 is basically the classes when we talk about polynomial regression, so that masking shouldn't be there. So 5 minus 1, which is equal to 4 here. Fifth question, consider a logistic regression where the predicted probability of the given point is 4.4. If the actual label for the data point is 1, what is the contribution of this data point to the log likelihood? Yes, come on. Logistic
0.4
regression.
by 0.6. Log 0.4 by log 0.
Okay. What about others? What is the distribution we consider in logistic regression? Like in LDA, we are considering Gaussian distribution. What about logistic regression? Am I correct? Am I correct by saying this formula? Taking the log. Log p bar y. Take it something. I shouldn't take p bar. Okay. Y is 1. In this case, 0. Can I say this is the answer? When we'll solve, the answer will be that only. Is it fine? The actual label for this data point is 1. So that's why I've taken 1. Come on, come on. Logistic regression, Bernoulli distribution. That is what I'm taking. Y log x. Maybe x I'll take. X power y, 1 minus x power 1 minus y. So plus 1 minus y log 1 minus x. So 1 is 1 log of 0.4. The other is 0. Okay. Okay, okay. It's like this. You can solve and get it. What about this? Sixth question. What additional assumption? Still you'll have any confusion, then you can ask me. What additional assumption does LDA make about covariance metrics? Now this is simple. We discussed in the last class that covariance matrix is same, but the mean is different for the LDA. Mean will, the shape will remain the same. The mean will be shifted. That's what we have done. What is the shape of decision boundary? We have done that. This is linear. These are linear separable points only we are considering here. Now, can you tell me about eighth? Now we have done only the Fisher criteria. Come on now. Don't tell me now you don't know. Come on. What was Fisher criteria? Let's see. Let's see the Fisher's criteria. This was Fisher's criteria. M2 minus M1 bar over delta 1 square plus delta 2. Fine. Now, M1 bar minus M2 bar. What is M1 bar? That is 1 minus 3. 1 minus 3 square, which is equal to 2 square, which is equal to 4, divided by delta 1 square plus delta 2 square. What is delta 1 square? 1 plus 4. So 1 plus 4, which is equal to 5. So it is equal to 0.8. Fine? Come on, class. Fine? Come on, come on. Only one thumbs up. What about others? Fine or not? Come on. 2 thumbs ups. Yes, Gaurav? Okay, he has gone. Yashwant, Preetham, okay. Yes, Sneh, Suma, Sachin, Narendra, Abdullah. Suma also. Okay. So this was the same Fisher criteria. Given two classes, C1 and C2 with mu1 and mu2, what is the direction W for LDA when the class covariance matrix XW is identity matrix? So how we'll solve it? Anyone? Yes, Mayank? Any idea? These are the questions you have already solved. Given two classes C1 and C2 with means mu1 and mu2, okay, what is the direction vector W for LDA? This is basically 1. So what is M2 bar minus M1 bar? 2 by 3 minus 5 by 7. Simply we'll do. But we see that the answer is not here. So let's try to normalize it. Usually when the answer is not there, let's try to normalize it. How we'll normalize it? Multiplied by which is equal to 5. Is it correct? Fine. Only one thumbs up. 2. Was it that tough? Or it was fine? Okay. Now let's try to solve our... Okay. One thing. Okay, maybe I'm not having that. Can you take the screenshot of it, and maybe what I can do is we can try, because this will take time, this numerical problem, these first two, you can take the screenshot and tell me what will be the answer of these two in the next class. I'll ask you first these two questions, then we'll proceed. Yes, Yashwant, what you asking? Why you have subtracted, ma'am? Okay. What is the, when we saw this, what is W here? W is M2 bar minus M1 bar. That is why I have subtracted. This is the formula where it is written that this is equal to identity matrix in the question. And this is basically the formula. So that's why I subtracted them. Is it fine, Yashwant? Though Mayank has also written, yes. Take the screenshot. Try to solve these two questions. Okay. Okay. Try to solve these three questions. We'll see this. Which statement about LDA and PCA is true? Write in the chat. PCA maximizes the distance between class means. LDA maximizes the total variance of all data points. LDA maximizes data between maximizes between class scatter while minimizing within class scatter. Or PCA requires class labels. Fourth question. What is the answer? I want everyone should participate. Like all 10 of you. Now 10 are only left, I think, because it's 8 o'clock. Come on, come on. What's the answer? Question fourth. What about others? Yes. What about others? Only 2 have responded. Exactly. It's basically C. So LDA is maximizing between the class scatter while minimizing within the class scatter. Two classes are linearly separable. Which statement is correct about the projected data using LDA? All points collapse to a single point per class. LDA always produces zero within class variance. LDA finds the direction that maximizes the ratio of the squared mean difference to the within class difference. LDA and logistic regression produce the same decision bound. So question fifth, what is the answer? Come on. What about others? Okay, yes. Only 2 have responded again, Suma and Mayank. Yes, Trisha, Yashwant, Sneh, Srinivas, Sachin. Come on. Exactly. It's C only because it's the same as just the wordings are changed here. And I want that you should solve this 3. Can you take the screenshot or photo of this? In the next class, we'll discuss about these 3 questions. Any doubts, any feedback regarding today's class? Though I thought about, I bought the MCQs for this SVM also. I thought that perceptron and SVM also I'll cover. Though, as usual, it takes time. So what do you want I should cover the MCQ part only, or the way we are going the whole maths part, like, or both. Like today I bought the MCQs, some MCQs. Maybe this we are unable to cover because we haven't covered this SVM and perceptron. In the next class we'll try. So is it going fine, or you want that only MCQs? Like how do you want in the next class? Yes, Suma, Mayank, and others. Nay, Sachin, yes.
Madam, this is Sachin. What I am observing, after going through videos as well as these lectures, and when solving the assignment, actually the derivations, there are lot many derivations we are going through, but eventually the questions are, I mean, it looks like that we are getting lost in those derivations, and then questions are little different, and those are I think around the basics. So that disconnect, I I feel that there is a disconnect. I mean, a lot of time has been spent on derivation, but I'm not sure how much that derivation will be useful.
Actually, I'm not trying to derive anything new. What I'm trying to do is whatever professor is coming from one point to other point, I'm trying to tell you how he's coming from one to other. You can't cram everything, na? Like, okay, first point is this, second is this. I'm trying to tell you how we are coming, because if you have to solve this SVM, like if you have to write this sorry, LDA thing within the class, this whole formulation, you can't cram, okay, this was the first equation. You should know like how from first to second we are coming. That's what my main motive was, to give you the intuition behind it. Okay, if you want more intuition based, less mathematics based, then I can go like that, and I can come up with more of MCQs. Is it fine?
I think
That's why
I
I
would
came
prefer
with.
that. Yeah, I mean, others can also comment, but
Okay,
this is
okay.
my general observation. I mean, it is now sixth assignment this week. The last 6 weeks, so many derivations, and no,
Actually,
sometimes.
no derivation. First of all, no derivation. I'm not actually deriving anything new. I'm just telling you what, like, about this also. If you'll see that, he came up with this step and then he came up with this. I'm telling you how he came up with this. At least you should know, na. You shouldn't go. You shouldn't be like, okay, this was this step and that was the other. Yes, Mayank, you are also raising your hand. Yes, you can't unmute, I think. Yes, Mayank, try to unmute yourself. Though I'll come up with the if you want. I was thinking that okay, you should get okay, it's fine if you want that. I'll come up with more of MCQs and more of theoretical part. It will be easier for me as well. It's not. Yes, ma'am, we can't solve the problems. Okay, but
Yeah.
my doubt is like why you are not able to solve the problems. Like what is the issue going? Like if came up with the assignment thing, I told you like each and every problem we have discussed in the class, na. Okay, maybe I'll not go with the derivations from the next class. Ma'am, can you understand Hindi if I write in Hindi also? Yes, sure, Mayank. I understand Hindi. I'm from Punjab only. Yes, you can tell. Okay, from the next class, I'll not go through maths and all things. I'll come up with the intuition things, and I'll for all the lectures, I'll come up with what is the intuition behind them. Is it fine? And the MCQs only.
Yes, I think.
Okay. Yes, Mayank, you are having any doubt? You're raising your hand. Okay, you were writing now, ma'am. Can you understand Hindi? If I can write Hindi also. Okay. So, any other feedback? So next class we'll try to focus more on MCQs. Is it fine if I'll bring MCQs only and try to make you understand just the intuition and then MCQs only? Okay.
Madam, it will also help, if you can spend some time on giving a broader view of matlab, for me personally, what is happening, we are so much into details, but the broader level, if we look at from the broader level, where are we at this point of time, that is also something not
Okay.
very
Okay. Okay.
clear sometime.
Okay. Okay.
And
I'll
at the
come up with
broader
some.
level, concepts of machine learning, and then
Okay.
different topics, and where are we at this point of time.
Okay. So I'll come up with like some short notes also, like what we have already covered, like shrinkage methods, what we have covered in this, what is in linear regression, what is in logistic regression, what is in LDA, how they are different from each other, when we have to apply which one. Is it fine? Like, should I come up
Yes,
with this?
yes, yes. It will be perfect.
Uh,
And if you can give some real time example wherever possible, I'm sure it may not be possible to give examples all the time, but at least some real time example that, this concept has been applied if data, because machine learning is all about having a huge database, and then applying various strategies of machine learning to, so some examples.
Okay. So I'll try to go through this. Like, I'll try to have a short notes also, like when we have to apply which model, how we have to deal with the data set, in which, like, I'll try to give example also, like for this type of example, which model is better, and what are the differences between each of the modeling, whatever we have covered. First, I'll try to do that, and then I'll try to give you the intuition behind each of them, and then we'll solve the basically we'll like go through more of the MCQs part. Is it fine now?
Yes, 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 madam. Thank you so much for considering this request.
It's fine. Actually, this is more tough for me. You will get that. Like, this is obviously it's because I have to prepare like how to come up with the other steps and all, and to explain you. It's more time consuming for me as well. But if you want to go on the other side, I was just in the impression that you should get the professor's lectures, like how he's going. Obviously, you can't get like from first step to second step how he's going and all. You will get the confusion. I was in the impression maybe you want that because in earlier classes I got the feedback I should go this way only. That's why I was going this way. So whatever you want, whatever you guys want, I'll go like go through that only. Like, okay. So next lecture we'll come up with more MCQs, more broader view how the different techniques are applied.
All right, all right. Thank you.
Any other feedback? Yes, come on. And one more thing, is it MCQ paper or exam, or is it theoretical as well?
I think it is MCQ.
Okay.
Yeah. Of course, uh, there will be some problems to be solved. I mean, some
That we,
calculations we need to do. Yeah.
okay, that's what I have also given you. The problems, some of the problems. This type of problems I'll give you in the MCQs also, so that you can also solve these. These problems will be helpful for you. Is it fine now? Like this way, I should move, giving the
Yes.
tuition, giving the MCQs and all. Okay. Okay. Thank you, class.
Thank you. Thank you.
Thank you.
Thank you.